Hi, good to see you again. Welcome to Block 3, Developing Numbers Sense, Lesson 8. I'll share my screen. So, in your previous lesson, you learned how to use known number facts to derive other number facts. In today's lesson, we're going to extend that principle and understanding to use known algebraic facts to derive other algebraic facts. So it's a very important lesson that links to your previous learning. Remember to like the video, subscribe to the channel, and share the video with those you think can benefit. Click on the notification bell so that when new videos are released, you will be notified. By doing so, you help us grow our mission to improve the mathematical literacy of children around the world, regardless of their economic circumstance. Thank you. Before we start, I would like you to pause the video and answer these retrieval practice questions in 2 minutes. Assuming you've paused the video and you've answered the retrieval practice questions, here are the answers. Let's discuss them. So for question 1, you were asked, if x plus y is equal to 10, find 3 different pairs of values for x and y that satisfy the equation. We can have various answers. We can have x equal 1 and y equal 9. We can also have 5 and 5. So x equal 5 and y equal 5. We can also have x equal 3.5 and y equals 6.5. The test here is to make sure that the pair of values you choose would always add up to be equal to 10. For question 2, you were asked to simplify the expressions by collecting like terms. By now, you should know how to collect like terms. I'm sure you've watched our previous videos where we did a lot of learning in algebra. So when we collect like terms, this will be 2a add 2b. So the a gets added to the a and the b gets added to the b. For this one, we have half c plus half c. So when we collect like terms, half plus half is 1. So half c plus half c is 1c, which can be written as c, and d at d is 2d. Okay, let's do some new learning for this lesson. Here we have a at b equal to 12 as a simple equation. We can represent this as a bar model. So remember, for your bar models, 2 bars next to each other are being added, and then we know that that bar is equal to the length of the bar that sits on top of that. So a at b is equal to 12. What about this one? How would you represent the bar model for this equation? Well, I'm sure you have thought, well, I just need to double A at B. So I'll double the bar model. Now, if you double the bar model, it means 2A at 2B is equal to 24 because 12 at 12 is equal to 24. I want you to have a think. How would you represent this bar model? Well, I'm sure you've thought that, well, we're going to have triple of the bar model for A at B equal to 12. So our bar model would look like this, which means that 3A at 3B is equal to 36. What about this one? How would you do this? Well, I'm sure some smart bunch, or some of you really smart, you would have figured this out, but let's go through the thought process and see how it works. So half A, if we have our bar model like this, it means we have to have the A and the B. Now, if we rearrange the bar model, we have the A sitting next to the B. So this is half A plus half B which should be equal to, of course, 6, because we have to have the 12 as well. Okay, here is another example. Y at Z is equal to 18. We're being asked to write an expression in terms of Y and Z that is equal to 54. I want you to have a think. What is the relationship between 54 and 18? Do you think one is a multiple of the other, and by how much? Well, someone would have thought that 18 is a multiple, or 54 is a multiple of 18. So 3 lots of 18 will be equal to 54. So which means we need 3 lots of this bar model. Now, if we rewrite this, this is what it should look like. So 54, which is 18 add 18 add 18, is equal to y plus z plus y plus z plus y plus z, which is 3 lots of y add z. So which means we can write this like this. And we can also write it like this if we collect our like terms and add the like terms together. All right, you have done some learning about how you can use some basic algebraic facts to derive other algebraic facts. It's now time for you to pause the video and answer question 1 in 3 minutes. Assuming you've paused the video and you've answered question 1, here are the answers. Let's discuss them. So for question 1, you were asked x add y is equal to 10. You were asked to use these known algebraic facts to work out the value of these expressions. And this is what you will get. So note here that we have doubled the x and doubled the y. So we have to double the value in which these variables add up to be equal to. And here we have tripled. Here we have made it 5 times bigger. Here it's half of this, x add y. So that should be 5. Here should be 5 as well. This expression is exactly the same as that one. They're equivalent. Here, note that we have added 7 to both sides. So we've added 7 to x add y, and we also have to do that to the right-hand side. Here, it's just been rearranged, but it's almost the same thing as this one. We've added 3 to both sides. And here we have subtracted, we have doubled it. First we doubled, and then we subtracted 11. So if we double this, this will be 2x plus 2y equal to 20. And then if we subtract 11, that will be 2x plus 2y minus 11. 20 minus 11 will be equal to 9. So you can see from your very first, practice how you have used a basic known algebraic fact to answer questions that could otherwise have looked challenging. Pause the video and answer question 2 in 1 minute. Assuming you've paused the video and you've answered question 2, here are the answers. Let's discuss them. So for question 2, Alex says, I know that A add B is equal to 7, so 2A plus B is equal to 14. Tommy says, I don't think you can work out what 2A plus B is. Who is correct? It's Tommy. Why? 2A add 2B will be equal to 14 because you've doubled each of the terms in the equation. But since we don't know what what A and B are, we can't work out the value of 2A plus 2B. So we cannot use this to answer this question. We must use known algebraic facts to derive other known algebraic facts. Okay, let's move on. Pause the video and answer question 3 in 3 minutes. Assuming you've paused the video and you've answered question 3, here are the answers. Let's discuss them. So here you can see that we've been given these known algebraic facts, P plus Q equal to 8. You've been asked to use this information to find expressions that would give these values, and we were just given 16. Now, if you think about it, we have doubled 16. So it means we have to double the variables. For B, we have made 8 4 times bigger. So we have to make the variables 4 times bigger. So we have to multiply each of the variables by 4. Remember, variables refer to the letters, okay? And the numbers behind the letters, we call them coefficients. So remember this. If you do not know what we're talking about, please go and watch our video in algebra, okay? Now, 4, here we have halved it, so it means we have to halve the variables. Here we have made it 100 times bigger, so it means we have to have this to be 100 times bigger. We can also write this as 100p plus 100q. Here we have 0.8 equal to 1/10. So having 0.8, you have made it 10 times smaller. So it means you can have 1/10 p plus q in brackets, or you can write them individually as 110p plus 110q. Here we have added 2 to the 8. So I want to write something. So here, if you think about it, it's a bit like saying P plus Q equal to 8 plus 2. Now, if you have added 2 to the right-hand side, it's just been written the other way around. You have to add 2 to the left-hand side. So this can be written as P plus Q plus 2 equal to 10. And of course, you can write it the other way around, which is this one here. Here you have 1. Now, if you think about it, how did it become 1? You should have subtracted 7 from the 8. So it means you have to subtract 7 from the left-hand side. So it's a bit like saying P add Q equal to 8 minus 7. Now, whatever you do to the right-hand side, you have to do it to the left-hand side. So this is P add Q equal to 1. So to have something that will be equal to 1, it means you have to subtract 7 from that side as well. So that should be the answer. Okay, minus 7. Okay, let's look at the second part of our lesson, and let's look at our first example. So here we have a bar model. How would you write, or what different equations can you write with this bar model? Have a think. Well, we can write 7 add y equal to 18. Have you also noticed that we can write y add 7, y add 7 equal to 18? Have you also noticed another equation that you can form when you use the inverse operation? Y add 7 equal 18. Yes, we've identified that one. But what about this one? 18 subtract y equal to 7. What about this one? 18 subtract 7 equal to y. So these are different equations that you can form just from this bar model. But what about this one? If you're given f minus g equal to 5, which variable has the greater value? If you're asked which variable has the greater value, how would you think about this problem? Well, again, you can, think about it by putting your bar model together. So f subtract g equal to 5. So f must be pretty much big. So our bar model would look like this. All right. So remember, you must have a very big bar for you to be able to subtract something from it. So that F must be the big bar, and then G should be the smaller one being added to 5. So we can actually deduce how many times bigger, or the number of amounts F is bigger than G by using this. So we know that F is greater than G. Why? Because if we rewrite this, we can say G at 5 is equal to F. All right, let's look at another example. Given that 2x plus 6y is equal to 16, which of the statements below are correct? Well, let's look at the first one. Have you noted here that we have halved the x term? Okay, we have halved 2x, which gives us x, but we haven't halved this one, and we have halved that one. So it means that is not right. Well, have a think about this one. Now, have you noted that we have divided by 3 here? We have also divided 6y by 3. That's why we have 2y. And we have divided 16 by 3. So if you think about this, it means this statement is correct. Well, think about this one. We have halved the 2x to give us x. We have halved the 6y to give us 3y. And we have halved the 16 to give us 8, but we have added 1 to the 8, which is 9. So this should be right, because whatever we do to the right-hand side, we have to do it to the left-hand side. So this is right. It's now time for you to pause the video and answer some practice questions. So pause the video and answer question 4 in 2 minutes. Assuming you've paused the video and you've answered question 4, here are the answers. Let's discuss them. So for question 4, 4a, you were asked, so you were given this known algebraic fact, n minus m is equal to 7. Which is the greater number, n or m? Well, remember the previous example we did, you can see that when m is subtracted from n, the answer is positive. So you can see that. All right. So n minus m should be greater than 0. So n is greater than m. And of course, you can represent this in a bar model, which we did. So remember, for you to be able to subtract from something, it means that thing has to be, quite big. So that should be n. And then we have to subtract m. So m must be smaller. And then that gives us a positive value of 7. So that gives us a positive value of 7. So if we rewrite this, we can say 7 add m is equal to n. All right. So n must be bigger than m, because for you to get a value equal to n, you have to add something to m, which is 7. All right. Now, what is the value of m minus n? Okay. So if you think about it, if we rewrite this, if we're trying to, make, use our equation solving skills, if we want to do m minus n, it means, if we rewrite this, it means we have to make the m positive. So we add m to both sides. So watch carefully. The reason being, we want to have the n on its own. So let's try that. No, let's use a different approach. I want to use a different approach. So, and I want you to think about this process I'm going to use now. So if we want to have, so we have n minus m equal to 7. We want to rewrite m minus n, which means we can multiply each of these terms by -1. So we want to change their positive or negative values. So if we multiply each of the term by -1, multiply each of the term by -1, we will have negative n, we'll have positive m, because negative times negative, you remember one of our lessons, is positive, and we'll have -7. So if we rewrite this, this will be m minus n equal to -7. And then next, you were asked to explain why m plus 7 is equal to n. We have just explained it here. If you recall, I explained it when we used the bar model. Pause the video and answer question 5 in 3 minutes. Assuming you've paused the video and you've answered question 5, here are the answers. Let's discuss them. So you were asked to use this information to find expressions that are equivalent to the following. So we've been given this known algebraic fact. We want to use it to derive other algebraic facts. So if we have 2c, I would like you to pause. Well, before we I explain. So pause the video and answer this in 3 minutes. Assuming you've paused and you've answered the questions, here are the answers. So here we have doubled c, so it means we have to double each of these terms. So that will be 2d plus 8, because 4 times 2 is 8. Here we have made c 3 times bigger, so we have to make each of the other terms 3 times bigger. Here we have made c 10 times bigger, so we have to make the d 10 times bigger. So by multiplying by 10, which gives us 10d, and then 4 times 10 will be 40. Here we have halved c, we have halved d. So this has been rearranged, moving the c to the right and d at 4 to the left. So, but it doesn't change what the result would be. We'll apply the same principle. So half, we've halved c, so we're going to have half d and half of 4, which is 2. Here we have c subtract 4 equal to d. All right, so if you rewrite this, c subtract 4 will be equal to d. Remember, how do we do that? By subtracting d from both sides. So if you subtract d, okay, so let me write it here. So we have c equal to d add 4. So if you subtract 4 from both sides, then you will have the d left on its own. And that will give you c subtract 4 equal to d. Here we have c add 5. Now, if you think about it, if you add 5 to c, then you have to add 5 to the other side as well. So imagine you have c equal to d. So this is what you have. So by trying to have this expression, something that will be equivalent to this expression, it means you've added 5, and for an equation, whatever you do to the left-hand side, you have to do it to the right-hand side. So if you add 5 to both sides, you have c add 5 on the left, which is here, and you have d add 4 add 5, which is d add 9. Pause the video and answer question 6 in 2 minutes. Assuming you've paused the video and you've answered question 6, here are the answers. Let's discuss them. So for question 6, you were given this known algebraic fact, 2x add y equal to 10. You were asked to find 2 expressions that will give an answer of 50. So here are the answers. Let's discuss them. So here you are asked to find 2 expressions that will give an answer of 50. So to get 50, it means you have to multiply that by 5. So it means each of these terms will have to be multiplied by 5 as well. So it means you have 10x plus 5y equal to 50. You could also have the expression like this. So you hold what you had before in bracket and then you write 5 outside the bracket. So these expressions would satisfy this answer. And then next you were asked, find two expressions that will give an answer of 5. Well, to get an answer of 5, you can divide that by 2. So it means this will be x plus half y equal to 5. Or you can hold what you had before in bracket and then write half outside the bracket. That's one expression you could get. You could also have this expression, which is to subtract 5 from both sides. Both would give you the same answer. Now, for C, you were asked all of these expressions equal 1. So work out the missing values. So if all these expressions are equal to 1, then the missing value is 10. And then here, the missing value will be 2x add y subtract 9. And then here, the missing value will be half x plus 1 over 10 y. And these are the answers. All right, pause the video and answer question 7 in 3 minutes. Assuming you've paused the video and you've answered the questions, here are the answers. Let's discuss them. So for question 7, you were asked A, B, C, and D are all numbers greater than 0. Decide whether each statement is always true, could be true, or is never true. So here you simply ask to write whether the statements are true, always true, could be true, or never true. So A is equal to C, could be true. All right. And then 2A add B equal to 2C add D could be true. And then for this, that's always true, that's never true, and that's always true. So you can use different numbers to test these statements. Pause the video and answer question 8 in 2 minutes. Assuming you've paused the video and you've answered question 8, here are the answers. Let's discuss them. So here you were asked if n divided by 2 is equal to 5, circle the correct statements. Well, here you can see that we have subtracted 3 from both sides, so this statement is right. Here you can see that we have multiplied both sides by 2, so this statement is right. And here you ask what are the correct answers for the statements that you have not circled. For the correct answers are n divided by 4 equal to 10 is the same thing as n divided by 4 equal to 5 over 2. And then 2n will be equal to 20. All right. So for them to be equal to the correct statements. All right. And that brings us to the end of our lesson. So in this lesson, you have learned how to use known algebraic facts to derive other algebraic facts. Well done for sticking around and for taking your learning seriously. Until next time, take really good care of yourself and bye-bye.